So here is another question on simple harmonic motion. So it is given that if the distance small y, okay, of a point moving on a straight line measured from a fixed point or origin or reference point and its velocity small v are connected by the relation 4v square is equal to 25 minus y square, then show that the above motion is simple harmonic in nature and find its time period. Okay, so here it is given that the position of a particle, okay, the position of this particle, let's say from this reference point or origin, it is moving here and there, the instantaneous position. So, and its velocity, it is given by this relation 4v square is equal to 25 minus y square. Okay, 25 minus y square. So that implies we can say v square is equal to 1 by 4 into 25 minus y square, or that implies v, only taking the magnitude into consideration, it is 1 by 2 into root over of 25 minus v square. This is the velocity of the particle in terms of the instantaneous position y or displacement y. Now let us consider simple harmonic motion. Let's say we have a simple harmonic motion which is given by, let's say, a sine omega t, starting from the mean position with 0 initial phase. This is the instantaneous position. Velocity is equal to dy by dt, which is equal to a omega cos omega t. Okay, so if we write cos omega t as root over of cos square omega t, it's all right. Then we write this as 1 minus sine square omega t, which is equal to a omega into root over of 1 minus sine omega t whole square. Now sine omega t is equal to y by a. Okay, sine omega t is equal to y by a. So if we make this substitution here, it will be a omega into root over of 1 minus y by a whole square. Okay, so that is equal to a omega into root over of a square minus y square by a square, or it is equal to a omega into root over of a square minus y square by a. A got cancelled, so that is equal to omega into root over of a square minus y square. Okay, this is the velocity of SHM in terms of instantaneous displacement y. Omega into root over of a square minus y square. So if we compare this equation, let's call it equation 2, and let's call this, name it equation 1. So if we compare equation 1 with equation 2, we'll see that omega, the angular frequency, that is equal to 1 by 2 radians per second. The amplitude a square of amplitude, that is equal to 25, that implies a is equal to 5. Okay, 5 units, whatever units it is taken, it is not mentioned here. So the amplitude is equal to 5 units, the angular frequency is equal to 1 by 2. Now what we are asked, we have to find the time period and also we have to prove that it is simple harmonic. We have already proved it. This is the SHM, okay, simple harmonic motion velocity, which is also in the same form as this. So we have proved that this motion of the point measured from the origin, that is also simple harmonic in nature, with amplitude 5 units, angular frequency 1 by 2 radians per second. Now we know that angular frequency is equal to 2 pi f, which is equal to 2 pi by capital T. F is frequency, T is the capital T is the time period. So the time period is equal to 2 pi by omega equal to 2 pi by 1 by 2, which is equal to 4 pi seconds. So the time period is equal to 4 pi seconds. So from the correlation of equation 1, which is the given relationship of velocity and instantaneous position, and equation 2, which is the basic relationship of velocity in SHM with the instantaneous displacement, we have proved that this is also simple harmonic motion in nature, and it has amplitude 5 units, angular frequency 1 by 2 radians per second, and time period is equal to 4 pi seconds. Okay. So here is another question on simple harmonic motion. So it is given that a particle executing linear simple harmonic motion has a maximum velocity of 40 cm per second and a maximum acceleration of 50 cm per second square. Find the amplitude and time period of oscillation. So first things first, first we have to write the basic equation of simple harmonic motion. Let's say x is equal to a sine omega t with 0 initial phase. This is the displacement equation. Then velocity, that is equal to dx by dt, which is equal to a omega cos omega t. Okay, that is the velocity. Acceleration, that is equal to dv by dt, rate of change of velocity with respect to time, or second order derivative of displacement, that is equal to omega square a sine omega t, that is acceleration. So if we only consider the magnitude, it will be omega square a. Okay. Now the maximum value of velocity, that is equal to when cos omega t is equal to 1, that is equal to omega a, and the maximum value of acceleration is when sin omega t is equal to 1, so that is equal to omega square a. This is omega a, that is omega square a. Now here it is given that the maximum velocity, that is equal to 40 centimeters per second, and the maximum acceleration is equal to 50 centimeters per second square. Now if we divide maximum acceleration by maximum velocity, that is equal to omega square a by omega a, we will have the angular frequency omega, that is equal to a max, which is 50 centimeters per second square, is equal to 40 centimeters per second. So this will be how much? 5 by 4 radians per second, that is the angular frequency. So the angular frequency is equal to 5 by 4 radians per second. Now we have been asked to find the amplitude and time period of oscillation. No, so here omega a, maximum velocity, we know it is given, omega is equal to 40, okay, 40 centimeter per second. So that implies A is equal to 40 by omega, which is equal to 40 by 5 by 4, that is equal to 160 by 5, that is equal to 32 centimeters, because the unit is in centimeters. So the amplitude is equal to 32 centimeters. Okay, 160 by 5, yes, 160 by 5, yes, 32 centimeters. And the time period T, that is equal to 2 pi by omega, because omega is equal to 2 pi by capital T. So T is equal to 2 pi by omega, which is equal to 2 pi by 5 by 4. So that is equal to 8 pi by 5, which is equal to, so it is coming around 5.03 seconds. Okay, so the time period is equal to 03 seconds. Okay, so here we are asked first to find the amplitude, then the time period from the given data, which was related to maximum velocity and maximum acceleration. Okay.